All right, hello everyone again. Uh, I think that we're almost at 2 o'clock time in France, and I suggest we begin the forum. Fleur, are you gonna present?
Yes.
Yes, like always. Thank you. Thanks for that. And
Mhm.
so few words just for the beginning. That I think we start by letting everyone join us the own pace as always. So good afternoon, everyone. Welcome to the forum of the It's the autumn forum, actually, of the European Irrigation Association today, at the end of November. For those of you who are joining for the first time, and I see people like keep on joining, so I'm very happy to see that we have a nice participation today with many people. So if this is the first time for you, so first of all, let me welcome you. My name is Moshe Bernstein. I'm the president of the European Irrigation Association. I've been active in the fields of the irrigation since 15 years. I live and work in France, and I'm the managing director of the company Netafim in France. So I'm very happy to see you all on behalf of the board and of the team who is presenting here this forum. I would like to welcome you, and I hope that you're gonna have a nice and beneficial and interesting forum today. We did the best to give you the content that we believe that is suitable for the association. Starting with like always with a few words about the rules of the house, as we call it usually. It's the same as always, to be very efficient and practice and to run smoothly this forum. You should, first of all, you should know, and this is the case here. I see that the forum is being recorded. If you don't want to be seen or you don't want your video, your photo, or your camera, just turn off your camera and don't display your name. But of course, if you don't mind being seen, please put your name properly. We know who you are, and we welcome you. Please mute, don't forget to mute your microphone while you're not participating. And of course, that you're more welcome to participate in the chat and to express your views and opinion and raise questions and so on through the chat. At a certain moments, we're going to open the microphones for everyone, and of course, it's gonna be open. The forum is open for everyone at the end of the forum to share their views and to have like an open discussion and conversation between us. So if you don't mind opening the cameras, it's always nice. We always like to see you as well. It just feels better. No pressure here, but I think it's always nice to do it. So if we move to the next slide, I think is the code of conduct. Yeah, it's always just for the avoidance of any misbehavior of this forum. Everything we do and in the association is what we call free competition environment. We strictly adopt a code of conduct in every interaction, whether in the board or in the forums, in the meetings, in the different sessions of the working group, and so on and so forth. Simply saying, we don't talk about commercial issues here. We don't have any. We don't talk about matters of pricing, clients, market sharing. We don't expose anything which is not public. And please, I urge everyone in this forum, the speakers and the participants, to concentrate on the reason why we're here, and to promote together the sustainable irrigation in Europe. And this is what we do. And the agenda for today, if you can move forward, please. Thank you. So the agenda for today, we're gonna open this session. Well, I'm the opener of the session. We're gonna share this. I'm gonna share this time the opening session together with my colleague Bruno Moll, that will open the door for on the what we call the most important project we're having in the association this year. It's the it's a taxonomy project. So Bruno will take us through this project for a few minutes, not more than this. Then we're gonna have as usual the ceremony of new members. Today we're going to introduce 8 new members that joined the association since the last forum, I guess. We most of the time with what we do is just we give them the opportunity to present themselves for you to know who they are. So this will be led by Fleur. Then we're gonna go to the main topic of today, which is the guest speaker, the first guest speaker, Claire Whitling, that will join us. I think that I already saw Claire here, so thank you, Claire, for being here with us. Claire will, from INRA, will talk about a very important term of the water use efficiency in the irrigation, and she will take us through this the explanation of what does it mean, how do we measure it, and of course we do believe that this the efficiency of water and the way we measure the efficiency of water is extremely important for the sector of the irrigation, no matter which kind of irrigation technology or method we're using. The efficiency of water and energy and all kind of measurements for efficiency will be crucial for the future of our sector as well. After we're gonna finish with this presentation, of course, you are more than welcome to propose ideas, to ask questions, to make remarks with Claire. I'm sure that Claire will be more than happy to answer and to develop this discussion. And then we move to what we usually do is the session of the innovation and technology. Usually this is the topic that we open the forum, we invite the members of the forum of the association to share new technologies, innovation, anything that is worthwhile technologically wise that we believe that has an importance to all the members. Usually we do it, we keep these sessions technical sessions. We keep it less and less, I would say, marketing oriented, but we give the platform for our members to show what they do and to be proud of it, and then to let us enjoy and to learn more for everyone in this forum. And on level. This time we're gonna take some time with Paolo Antini from the company Centex that will share with us a new tool of multi-level data interpretation. That this will bring us to the end of the session of the forum. We will open the microphones, and hopefully we're gonna have also like a side discussion and conversation between us. I think that at this point, maybe a few words about the association, and then we'll move right to the topic of the taxonomy and then to the speaker. So just few words from my side, even before we start the sustainability. Yes, thank you. But a few words about the activity of the association. So I would say that we are quite busy and active in the association. If you remember, for those of you who remember, you may be aware that since 3 years, the way we function, the way we work in the association is the activity is being carried out through what we call working groups. We have 6 working groups today: sustainability in agriculture and the urban landscape and standardization and norms, training and knowledge transfer, water reuse, reutilization actually, and the communication. These are the working groups that we have. Each working group is being the head of each working group is one of the board members of the association, and each working group is taking topics of which have relevancy to what we do in the irrigation sector, and develop it more with the help of members, volunteering members to these groups. By doing this, what we believe we can bring to the table is the place of the irrigation, the voice of irrigation, and into the relevant discussions all over Europe. What we're doing mostly this year, and I think that this is worthwhile mentioning, is dealing with the sustainability. This is the main project we're having today. Sustainability working group is being led by Julia. I'm not sure if Julia Giuffre is here with us today. Usually but Julia is leading this from the company Iritech, is leading this group of sustainability. And the main project this year is under the responsibility of this group, and it's the topic of the irrigation and taxonomy. For those of you, this is the first time for them for you to be introduced to the topic, to the term taxonomy. Actually, taxonomy regulation is a kind of is a classification of what does it mean that serves the transformation of the EU economy to meet the European goals, environmental goals, the Green Deal, the environmental objectives, and the climate neutrality targets. We find this to be extremely important for the irrigation sector because the irrigation sector is not being represented under the terminology of the EU and under the terminology of the what we call economical activity. This project is being executed. It will be presented now by Bruno. Just one word about the execution of the project is with a company called the House of Ambrosietti. It's a consulting firm, think tank, specialized in the region of the EU and the sustainability. And there is a lot of help that we're receiving from many people. I'm sure that some of you are in this call now in the forum. Many different members and non-members that are joining forces together. Different areas of irrigation, technologies, different aspects of what we do. And together, we're building the infrastructure as we believe is the truth. We're building the infrastructure for the future of sustainable irrigation in Europe. So without further ado, I think that Bruno, if you are available and the microphone is open, please take the lead on this one and tell us a little bit about this project.
Okay.
Thank you.
Okay.
You see the presentation, Bruno? Because Jean-Maurice told me that we don't see well the presentation. You do or not?
I see it. I see it.
Ah, you see it.
No,
Okay, okay.
I can see it without any problem, with good definitions and so on.
Good. Thank
Okay,
you.
so a short highlight on the sustainability activity, and in particular on the way we can address sustainability through the tool that is proposed by European Commission, which is the taxonomy. So what does it mean? How we can do? Where are the reference that we can find are the questions that we are trying to address in this short presentation. Next one, please. So sustainability is present, or the vocabulary of sustainability is always present in the talks that we can hear. As the climate change evidence are accumulating, the actors of the sectors need to think about the ways to face it. And one of the ways is to achieve more sustainability in the economic activities. As of today, the Paris Agreement has established objectives that have to be translated in actions while respecting the 17 UN SDGs, the Sustainable Development Goal. The problem remains that references are not so numerous and are really necessary. Some certifications are existing, but they mostly concern the final product at farm level and not all the ways to achieve this production. Here comes a European project on taxonomy of economic activity, which have been elaborated by the Commission as of today. So first, European Commission classified and described the main economic activity in terms of impact on climate change. This initially concerned 103 activities divided in 13 sectors. The sectors that have been addressed are the sectors that are most impacting on the climate change. So not irrigation, not agriculture, as it is considered to be addressed partially by the Common Agricultural Policy, but more the energy production, the transportation, and regarding the water, the question around water supply in cities and water and wastewater treatment. You probably have heard about that last year, where they were arguing between different countries in the EU regarding the production of energy, classifying the green, gray, and black energy production. So we are in the same logic here, but on the different sectors. This is enforced today for the biggest company in Europe from 2023, which concern about 11,000 companies in Europe. In a second step, this will be extended to around 55,000 companies in Europe from 2025. Agriculture, as I was saying, is not yet concerned, as the Common Agricultural Policy was under negotiation when the first attempt to classify or to elaborate the taxonomy was made. So at the beginning, the work concentrated on two climate objectives, which are mitigation and adaptation to climate change. And further, it was extended to the environmental objective, which are four on water resources, pollution, circular economy, and biodiversity. All the companies that are targeted by the classification are, for the biggest one, and will be from 2025, submitted to the publication of their CSRD, which is a corporate sustainable report that has to be disclosed. So, as I was saying, considering irrigation sector, we notice that this sector is not under this classification. So EIA decided to launch work to evaluate the way that irrigation sector could address this new policy. So it was launched in the second half of 2023 and will be applied at the 15th of December. Next, please. So what is the content of the project? First, we have that was conducted, as Moshi was telling us, with the Ambrosity House. The first part of the activity was to identify what are the challenges the irrigation sector is facing, and in particular will face to address sustainability transition. This sector is today marginally or not represented in the taxonomy, despite its strategic position, in particular toward the water saving issues that we are all facing. So the project goal was to design technical and strategic, or to approach technical and strategic dimension of the future development of the sector, and identify the key message for structured communication and advocacy. And finally, develop a future proof process guideline for the EU taxonomy application to the benefit of the EIA's company and further all the companies of irrigation sector. Just when we launched the project, we were not informed about the process that was undergoing in the EU, and mid-October, the EU has opened a window of opportunity to amend or propose to amend the existing taxonomy or to propose the new taxonomy until the 15th of December. Consequently, our project and the delivery that we intend to give are just coming in the right time. Next, please. So the project was divided in 3 times. The first was establishing the state of the art, trying to identify what are the classifications that are existing. We identify about 35 classifications, but not adapted or not fully adapted to our sector. Then identify the different sectors. Next, please. Identify the different sectors that are covered by our activity, that was considered four. The first is on manufacturing and distribution, the second of irrigation equipment. The second is on system design, installation, and end of life, then on consulting, training, and communication, and finally on technical and scientific research on irrigation. These are the four families and the 15 targeted topic or sectors that we have identified that are further analyzed, next please, that are further analyzed in their capacity to address the 6 objectives of the taxonomy. So we are currently working on this part of the activity, which is the second part, try to define the criteria for the 14 sub-activities that allow to address either the climate objective, adaptation and mitigation, or the environmental objective. Water resource preservation, pollution prevention, circular economy, or biodiversity. In the meantime, we are preparing an advocacy paper that is summarizing the work that we are doing and that will be applied to the Commission for advocating for the consideration of taxonomy by the European Commission. Next, please. So the key priority which are guiding our project on the EU taxonomy are the following: sizing a significant opportunity for the competitiveness of the sector and its companies. The goal is to achieve the inclusion of irrigation industry within the tool that investors and member states are using to integrate sustainability into their decision-making processes. A failure to recognize the sector as sustainable will result in major constraint in the future business growth, as the future financial allocation will be submitted to the respect of the different objectives that was mentioning previously. The objective is also to identify the true essence of products and the role in the sustainability transition, and finally creating a common vocabulary for the industry, the finance, and the policy makers. Next, please. No. Okay, so the final, as I was mentioning previously, the final product of this project will be a policy paper that is, I would say, 80% written, and that is introduced by a definition of the sustainable irrigation that you can read here. As I mentioned before, all this work will finish on the 15th of December. The next step will be carried out in 2024. That will be answering to the question of the Commission that will come to build the sustainability criteria that we are proposing. As I was mentioning, there will be 2 types of criteria: qualitative criteria, presence or absence of a system, and quantitative criteria, giving thresholds that will help qualify as sustainable a system or not. And for this second step of the work, we will need all the contribution of the members, of course. And if you are concerned by this and not yet member, please come with us. Thank you very much for your attention.
Thank you.
Thank you.
Sorry.
Thank you very much. Well, that was a little bit longer. Just the last word about this is a very good moment for me to thank all the people that are contributing a lot of time. In this project, I can count at least 20 people from the organization that are really dedicating the time to contribute. And the policy paper will be shared with the members of the association at the end of the year, I guess. If you would like to, if someone here is not a member of the association and would like to have to get the paper, please make contact with Flo, and you are more than welcome to join us and then to enjoy the fruits of this as well. It is very important. Thank you. I leave the stage now to you, Fleur, to continue with the introduction of the new members.
Okay, thank you, Mashi. So now we are going to move to the next part of the forum, which is a welcome to new members. The association is growing very fast, and actually we are very proud to say that we have 85 members. And since our latest forum in March, we welcomed 8 new members. So I am going to call them one by alphabetic orders. And now they will have the opportunity to introduce themselves and their company. I ask all of you to be short, and to respect the time of the forum. So you have about 1 or 2 minutes to speak. So the first company is DVS Berengnung, and I would like to call Andrea Maurer, if you are here.
Hello. Do you
Hello,
hear me?
Andrea. Yeah, we do.
Okay.
Yes.
So I'd like to introduce DVS Berengnung. We are a company situated in Tübingen, Germany, south of Germany. And we do irrigation since 2014. We specialize in plug and rain product concept. So we pre-assemble irrigation to be very fast and easy on the site. We specialize in irrigation planning software, and we try to be a good provider from training and advice until logistics. The second slide. So this is our 2 major things that we work on at the moment. So we have an online irrigation planning tool that can be used to design house garden projects. And we work on sensors, soil moisture sensors, to enable sustainable irrigation in the future to save resources. Thank you.
Thank you, Andrea.
Thank you, Andreas. Welcome. And thank you for respecting the time, the 1 minute
Thank
time.
you.
Thank you. I appreciate it.
Okay. So the next new member is Gardena, the company Gardena, German company, and I call Daniel Held to present Gardena.
Hello, everybody. Thank you for giving me the opportunity to present Gardena. My name is Daniel Held, and I'm responsible product manager for automatic watering solution. I mean, Gardena is the brand for residential garden. We work mainly on sustainable choices, and we try to give sustainable solution to the customer on irrigation side, but also on the material side. We deliver superior quality to our consumers, and we drive innovation through easiness and convenience. And by that, we support our customer group by realizing gardening dreams. We work, as I said, for residential gardening. We have different product solutions. We have the traditional spray guns and hoses, but we have also irrigation solutions like micro drip system, pop-up sprinklers, and the various irrigation controls. One of our values is efficient irrigation. We have several solutions in our portfolio: sensor solution, drip irrigation solutions, and specific pop-up sprinkler, as I said. But not only this is our focus, we want to go beyond that and create sensibility for our customer group on efficient irrigation and the scarce resource of water. And I think this is a very big similarity we have also to the European Irrigation Association, and that's why I believe it's very valued to be there. And thank you for giving me the time for introduce the Gardena brand and our products.
Thank you, Daniel.
Thank you, Daniel. Welcome.
Welcome. Next new member is Hanan Iskovic, a consultant based in Israel. Are you here, Hanan?
Yes, I am, of course. Thank you for the opportunity. Now, if Gardena can introduce themselves in 2 minutes, obviously I can do it faster. My name is Hanan Itzkovich, and I'm a business consultant doing business development, specialized in irrigation and smart agriculture. I have vast experience working with companies in Europe, of course, in the United States, which is my specialty. And I'm working with companies that, can you change to the next slide, please? And,
There is just one slide, I think, sorry.
okay, so you can go
because,
back
but you can talk about
okay.
the company you are dealing with,
No, that was, I changed it. Anyway, sorry about that, guys. And what I also specialize is I'm a qualified coach of the European Union. I work with the small-scale startups that receive fund or looking for fund from the European Union, and how to help small company startups working with large-scale companies. You have my details. I'll be happy to talk with any of you separately. Thank you, and I'm glad to join the European Irrigation Association.
Thank you, Hanan. Welcome.
Thank you, Hanan. Welcome.
Yeah.
Thank you, guys.
Yeah. The next one is IDBD, Elie Desrues.
Hello, everybody. Thank you for being a new member. I'm very proud of that. Our company is an independent irrigation consultant working mainly in the turf business for golf, sports field, and landscape. So we are able to provide services on audit, design, site supervision, education, water management. I am working with Felipe Mendieta, who is a civil engineer, major in hydrology and urban water works. Felipe Mendieta has a civil engineering degree in France, but also he is coming from Bogota, Colombia. So this means that we can talk in French, English, and Spanish in this company. And myself, I have been in the turf irrigation business for many years. First in the distribution with the design and education, and also as a member of the European standardization for the European standard on turf irrigation. Recently, I have accepted to be part of the European Irrigation Association Working Group number 4, and we are also willing to participate to the Working Group 5 and Working Group 2. I believe that's it.
Thank you, Elie.
Thank you. Welcome, a lot of you, and thanks for sharing this experience with everyone and being active in the working groups. Well appreciated.
Yeah. So next company is Ocmis, Italian manufacturer, and I will ask Alex Donzelli or Maria Benassi to introduce Ocmis. Yeah. You are Alex? Are you here, Alex Donzelli? No? There is nobody from Ocmis in the forum? Okay, so I will say a few words about Ocmis if nobody is here. It's a company founded in 1970 and today is the world leader for hose reels. And they're offering the best solution for market needs. The production site is in Italy, in Castelvetro di Modena, and the project ranges are divided into hose reel, micro-vane, center pivot, and motor pump. This is what I know about this company. So if they come later, we will maybe give them the opportunity to introduce themselves later. Okay, so we will move to the next company, which is Pipelife, and ask to Konstantinos Akritanis to introduce Pipelife.
Hi, I'm Konstantinos Akritanis from Pipelife. Nice to meet you. Thank you for accepting us in the association. We in Pipelife is a company that produces mainly pipes and whatever it is around it. Pipes for buildings, infrastructure, and one part is the agriculture. So you can go to the next slide. There are factories all over Europe, almost 24 factories. And one part is the production of the irrigation pipes, fittings, and together with the team, you can go also to the next slide. We created this one-stop solution for all the whatever is needed for the irrigation part, the precision irrigation, in drip irrigation products. And also you can go to the next slide, what we call the one-stop solution. So we included all the products that we need in the irrigation part, like drip irrigation pipes, sprinklers, fittings, filters, fertigation automation, and pumps, in order to offer to the customers this sustainable package that we are trying to offer. So I hope that we have a nice input in this association, giving also our part for the sustainable future. Thank you.
Thank you, Konstantinos.
Thank you. Welcome.
Welcome.
Nice to meet you.
Yeah. Next company is Poelsan from Turkey, and I will ask Talha Nefes to say a few words.
Hello, everyone. Hello, my name is Talha Nefes. I am working for Poelsan plastic company in Turkey in export department. So I will make a small presentation of our company. Can you make the next slide, please? So Poelsan is the first company who produced compression fittings in 1994. So we are producing compression fittings, clap saddles for irrigation pipes, for agricultural irrigation, water network, landscape, and etc. We are one of the leaders in Turkey, and we're exporting more than 75 countries around the world. Next slide, please. So this is our products. So we have compression fittings, PN16 compression fittings, PN10. We also now start producing, spray and nozzle for automatic irrigation system this year. This is also our other products. Next slide, please. This is also the other products that we're producing, fittings and accessory for drip irrigation pipes, drip tape pipes, etc. And also we'll also start producing electrofusion fittings next year, we hope. So yeah, if you want, because it's a little long, so I want to make it quick like the other presenter, so you can finish the presentation. Okay. If it is okay. Thank you very much.
Thank you, Talha. Thank you very much.
Thank you. Thank you. Thank you.
And the last one is Christian Döschner from Wiscon Company.
Hello, everyone. Thank you for giving me this space to introduce myself and the company. Next slide, please. Very quickly, we are a Chilean company founded in 2006. It's a very challenging country to make agriculture. Water is the main, the most difficult resource to deal with. So we have created a technology to make to help the farmers to improve the decision making in terms of irrigation and the execution. We currently have 5 offices. I am in charge of the office in Spain, and also we have an office with my colleague Marco Bezzi in Italy, in Trento. We currently have more than 100,000 hectares in control in 12 different countries. Next, please. And we have developed and patented a solution called Drop Control, which is an irrigation and fertigation automation system with a very strong concept about integration of different technologies. We take care of the entire journey of the irrigation water from its extraction at the source to its application in the crop through the irrigation. So we are very happy to be a contribution here to the association. Yes, we hope to collaborate in whatever is needed. Thank you very much.
Thank you, Christian.
Thank you, Christian. Welcome.
Welcome. Okay, so here is a map with the logo of our 85 members. What I would like to say is if you want to present your product or technology in more details, you can be candidate to participate to the innovation technology session we have at the end of the forums. You will see Paolo Antini will do this presentation this time, but you can candidate for another time because we have 3 forums per year. So now we are going to move to the next part of the forum with our guest speaker, Claire Serra Whitling from INRAE, and she's going to present you water use efficiency of irrigation systems.
Good afternoon, everybody. My name is Claire Whitling. I'm working at INRAE, which is the French National Institute for Research in Agronomy and Environment. And I'm pleased to be with you today for a short presentation entitled Water Use Efficiency of Irrigation Systems, What Water Savings Are Possible. Next, please. So I will address 3 questions. The first is, what is exactly irrigation water use efficiency? The second is how to save irrigation water. And the third one, what irrigation water savings can be expected. Next, please. So first, to remind us what is irrigation water efficiency. So we have to look at the way of the water from the water resource to the plant, to the field and the plant. You can see that the water is first under pressure, then it is transported to the plot. Then it is distributed at the plot level. Then when we speak about sprinkler irrigation, water goes through the air and then at least reaches the soil. Then it is absorbed by the plant, transpired by the plant, and then it allows the yield of the crop. And at each step of this way of water, losses can occur. Losses through leaks during transport, leaks during distribution, leaks in the irrigation equipment. Then in the air, losses through direct evaporation or through drift due to the wind. And then after having reached the soil, water can be lost by runoff at the soil surface, by drainage, by soil evaporation, and at least also by a residual stock of irrigation water in the soil at harvest. And so global irrigation efficiency at the plot level is the ratio between the volume of water that really benefits to the crop to the volume of water at the plot entry. And we define the irrigation global efficiency as the ratio of the volume of irrigation water actually transpired by the crop to the volume of irrigation water entering the plot. There is also another indicator called irrigation water productivity. That is the supplemental yield allowed by irrigation to the volume of irrigation water entering the plot. Next, please. So this is another way to represent exactly the same process. You have here in green the rainwater and in blue the irrigation water. And you can see the same steps I explained you earlier for the irrigation water. First, the water is entering the plot. Then you have the volume that is actually applied. That is the volume that exits the nozzle or the dripper. Then the volume that reaches the soil. Then the volume that is stored in the soil. Then the water volume evapotranspired, the water volume transpired, and lastly, the yield allowed by the water volume transpired. And between each step, losses can occur. These losses can be leaks from irrigation equipment, direct evaporation and drift for sprinkler irrigation, also interception and storage by the crop canopy. Then the volume between the volume that reaches the soil and the one that is stored in the soil, runoff or drainage losses can occur. Then another loss is, as I explained, the residual water in the root zone after harvest, also weed transpiration, and at least we know that also soil evaporation can occur. And in orange here you can see the global irrigation efficiency, that is again the ratio between irrigation water actually transpired to irrigation water entering the plot, and irrigation water productivity, the supplemental yield due to irrigation to irrigation water entering the plot. Be careful because sometimes water productivity is the total yield reported to the water entering the plot. But here, when we deal specifically with irrigation water productivity, we have to take into account only the supplemental yield allowed by irrigation. And so improving irrigation efficiency means, in fact, reducing these irrigation water losses at the right of the scheme, and this means saving water. Next, please. So now move on to the second question, how to save irrigation water. I will speak about 3 types of levels: agronomic levels, technological levels, and irrigation scheduling levels. And I will also present some examples for each point. Next, please. Concerning the agronomic levels, you know that we can choose species and varieties with specific irrigation water needs. Here you have a large panel of various species and their irrigation water requirements in the south of France. And you can see that some species like kiwi fruit, alfalfa, peach, pear, apple have high irrigation water requirements, and some varieties have lower irrigation requirements. And it is interesting to see that early varieties have specifically lower water consumption than later varieties. So here when choosing varieties that have a lower irrigation needs, when doing that, we don't improve really irrigation efficiency because we don't act on the water losses at the right of the scheme, but we try to reduce the volume of water that is transpired, and especially we try to increase the volume transpired that comes from the rain, so to reduce the water transpired that comes from the irrigation. Next, please. This is another example of agronomic lever. This is the avoidance strategy. It means reducing the vulnerability to water shortage by avoiding drought periods. You can see on the scheme the sensitivity of maize to water stress through the different months of the year. In orange, we have the traditional sowing dates of the maize, and so that's the stage that is very sensitive to stress occurs during July and August, when the stress level is very high. And when shifting the sowing date to early dates, we shift the sensitive period in months June, where the stress level is lower. So with the green curve here, you can see that the higher water needs are outside of the drought period. So here again, we don't act on improving efficiency, but we act on taking more benefit of rainwater for water transpired by the crop. Next, please. Again, an example of agronomic levers. Soil management is very important when considering irrigation efficiency. Here you can see an example of conservation agriculture. We have here in Montpellier on our platform some plots that are conducted with conservation agriculture practices. That means no tillage at all, a permanent soil cover, and a long crop rotation. You can see here on the picture that after a rainfall of 28 millimeter in June, we could observe a flaking in the conventional plot, whereas not in the plot conducted under conservation agriculture. What happens here? Here it is that we increase water infiltration in the soil through the conservation practices. So there is an increase in the water volume penetrating the soil, and therefore a reduction of flaking or of runoff. So in this case, you can see on the scheme at the right that we have reduced the runoff losses, so we increase irrigation global efficiency. Next, please. This is again with conservation agriculture. On the picture, you can see the soil surface under conservation agriculture on the left and under conventional tillage on the right. And you can see that conservation agriculture practices increase soil roughness so that infiltration is also increased and runoff is decreased. Also, under these practices, the aggregate stability is enhanced so that soil sealing or soil crusting is reduced, and therefore infiltration is enhanced and runoff is reduced. So again, by reducing runoff losses, we increase the global irrigation efficiency. Next, please. Here again, in conservation agriculture, you can see the effect of crop residues on soil evaporation. Soil evaporation is presented here with no mulch at all on the left, and on the right with two different mulches. And you can see that mulch reduce the irrigation water evaporation from the soil. So on the right scheme, you can see that by reducing losses by soil evaporation, we increase the global irrigation efficiency. Next, please. Now a few words about technological levels, that are the levels that concern directly irrigation equipment. First of all, it is important to improve application uniformity. You have here an example of a solid set system, and you can see the amount of water applied at each point of the plot. On the left with a high wind, and on the right with a lower wind. And you can see that the uniformity coefficient is 80% on the right, 40% on the left. So here, when the wind is lower, we have lower over-irrigated and under-irrigated zones, so that we have a reduction of runoff and drainage losses. So again, here on the left, we have a better global efficiency. Next, please. Here also a technological level dealing with the time of water application. On the graph, you can see in black color the losses by direct evaporation in the air in sprinkler irrigation in a very, very warm day in the summer. And you can see that the losses very occasionally are higher than 20%, but for a 24 hours period, it is less than 9%. So this is why it is recommended to avoid irrigating between 11 a.m. and 3 p.m., of course, when it is possible. Next, please. Now, an example of saving irrigation water with scheduling levels. Here you have the irrigation amount for zucchinis in the south of France. In red, it is the irrigation amount used when scheduling with the maximum evapotranspiration of the crop. And in blue, you have the irrigation amount when scheduling with tensiometers. And in yellow, you have the water saving. It is almost 70% in 2016 and 50% in 2015. So here, when we really adapt the water amount applied based on the tensiometric status of the soil, we can save water because we avoid the two important water amounts applied, and therefore we reduce losses by drainage. So with this scheduling system, we also improve global irrigation efficiency. Next, please. So now what irrigation water savings can really be expected? First, with the agronomic levels, I have to say that still Too few references have been collected on achieved water savings. So we have to continue our research work. Just to say you that in the Bagage project that took place in the southwest of France, it was observed that farmers under conservation agriculture irrigate exactly in the same ways as conventional farmers. That means that these farmers do not take advantage of the new properties of their soil, and so they do not know how to adapt their irrigation to their new properties of soil. So there is an urgent need to acquire references on irrigation water requirements for conservation agriculture and in general for other agroecological practices. Next, please. Concerning the irrigation water savings that can be expected by technological levels, one way, of course, is opting for a more efficient irrigation system. Here you have the result of a study conducted by Bruno Moll and myself in 2017, and you can see on this table the water savings that can be expected when shifting from system 1 to system 2. For instance, when shifting from a solid set system to a surface drip, you can expect 15 to 25% water saving. This is a referential for corn and field crops, and the same type of tables was also established for perennial crops and vegetables. Next, please. And the same type of tables was also established for water savings expected with the scheduling levels. You can see the different water savings that are realizable with tensiometric or capacitive probes. Next, please. A slide to see how the hydric deficit of the cropping season can affect the water savings expected. On the left, you have the water savings achieved by changing irrigation system, so changing from a sprinkler system to either a surface drip system or subsurface drip system or micro sprinkler system. First, you can see that the water savings are highly variable, ranging from 0 to 70%. So this means that water savings, we cannot generalize the water savings observed. And these water savings are plotted as a function of the hydric deficit of the cropping season. This is the ratio between the potential evapotranspiration and the precipitation. So when you go to the right of the graph, you go to the more and more dry years. And you can see that the water savings achieved with the localized irrigation systems compared to sprinkler systems decrease when the drought level of the cropping season increases. And when the hydric deficit is higher than 4.5, water savings seem to be impossible. On the right, you have the same graph with the water saving achieved by using soil probes for irrigation scheduling. First, you can see that there are no references for very dry years, so we have absolutely to collect references for this type of years. Nevertheless, you can see that we do not observe the same trend, and the water savings obtained from irrigation scheduling using soil probes do not seem to be influenced by the hydric deficit of the cropping season. So from a climate change perspective, it's important to keep in mind that a greater potential for water savings can be expected by adopting irrigation management tools, for instance, irrigation scheduling tools, rather than changing water application technology. Next, please. Here, I have extracted one point of the previous graph. You can see on the right the total irrigation amount used for irrigation of corn with a spray gun on the right and with a subsurface drip system on the left. And you can see that the water saving observed was 63% in 2007 and 18% in 2009. Next, please. And we wanted to know what happened between these two irrigation systems, between spray gun and surface drip. Where do the irrigation saving come from? You can see, for instance, for 2009 on the right of the graph, you have the total irrigation amount for both systems, spray gun and subsurface drip. In green is represented the amount of irrigation water that was actually transpired by the crop. So this is the irrigation water that was beneficial for the crop to produce the yield. And this represents the global irrigation efficiency of the system. You can see that it is almost 50% for the spray gun and 70% for the subsurface drip system. And all the water amount that is above this green amount represent losses. You can see that there are different losses. For instance, soil evaporation in yellow that occurs with the spray gun system. Of course, we do not find these losses with the subsurface drip system because the water is applied underground and therefore cannot evaporate from the soil. In brown, you can see the losses by drift and direct evaporation in the air. And again, of course, these losses do not occur with the subsurface drip system. So these two kinds of losses, soil evaporation and drift and direct evaporation, are typically linked with the technology of the irrigation. Other losses, like drainage in red, are more linked with the scheduling of irrigation, as well as also the losses in orange by residual soil water after harvest. And you can see that with the subsurface drip system, a better scheduling would have allowed to reduce these losses by residual water stock after harvest. So here you can see that with the modeling approach, we can distinguish between the technical losses linked with the type of system and the tactical losses that are linked with irrigation management and scheduling. Next, please. So as a conclusion, as I said, improving plot level irrigation efficiency means reducing irrigation water losses and means saving water. how to improve plot level efficiency. First of all, and the first is very important, through cropping practices. So these are the agronomic levels I have explained, to make a better use of rainwater and then, if necessary, of irrigation water. Again, references on water savings are still lacking. We have to continue our work to collect such data. And then the second type of levers to improve efficiency is, on the one hand, modernization of irrigation systems, and on the other hand, irrigation scheduling. Concerning the first point, modernization of irrigation systems, significant progresses have already been done. And as you have seen, the potential of water savings remains low in dry years. For the second point, irrigation scheduling, we can say that these tools are still underused and large progresses have to be made. And also, irrigation scheduling shows a higher potential for water savings in dry years than changing irrigation systems. So to promote water savings at the plot scale in the context of climate change, along investments in water-saving equipment, it is very important also to support improvement of irrigators' practices and, in particular, irrigation scheduling tools. But please note that saving water at the plot level does not necessarily mean saving water at the territory level. I don't have the time to develop this point, but if we want also to save water at the territory level, we have to add policy and regulatory points to the improvement of equipment and practices. I thank you for your attention.
Thank you, Claire, for this very interesting presentation.
Thank you, Claire. Let's well, I've got some questions, but let's open this for everyone. If you have any, please, your questions or comments are welcome to Claire. So anyone has a question or anything to comment? Andreas, I see, but please open your microphone if this will be.
Hello, Claire. Thank you very much for this nice presentation. One question came into my mind when you talked about soil probes for water or for decision making. Is this feasible, or how would you approach this, that it's really been applied in the field, that people work with this method?
For me, it's a very confident method, so reliable method. But you're right, it is sometimes difficult to be applied in the field by the farmers. Although we know a lot of farmers that use these materials, but it's true that we as researchers know a lot of farmers using these tools, but the farmers we know are already interested in research and in improving their practices. So this is not a generality. And indeed, the proportion of farmers that use these tools, either capacitive probes or tensiometers or other physical tools, this proportion is very low. And one of our message is that we have to generalize the use of these tools.
Thank you.
Thank you.
I have a question too, Claire. Well, I'll pick only one. A few comments. First of all, I really like the fact that there is the understanding of the tactical losses, and not only the technical. It's not only about the technology that you use; it's also about the best practices. This is the notion that needs to be promoted more and more in the field, because this leaves a place for all the technologies and all everything that the sector has been doing for many years. And we all do we all take the same direction for the saving of water. So this is very encouraging. I was quite disappointed to find out that there are no references. We keep on talking about this years over years that we don't have references. And it's a shame because so many years we have also us as a sector, as companies, we have so much experience, but we never managed really to accumulate enough research, like R&D and practical experience and references to support to continue promoting this. So the question arises again. We have, like, how do we make this link between what you're presenting here and it's a very practical question, like the research and the business. Can we get along, like to make this link that we can use your research and the research can use our experience to, whether in the framework of the taxonomy or any other framework that we try now to develop. We want to put these terms in a concrete way to push the sector forward. So do you have any idea? I know it's kind of a tricky one, but
your association is a very good mean to make the link between business and research, and I'm sure that all the companies represented today have data concerning the water savings obtained by irrigation scheduling, I'm sure. But you can make the link between both of us.
What? That's a big job. Okay. Okay, I understand.
Yeah. May I just add a detail on this, because I was part of the study at the time where we did it with Claire. When we spoke about the experiment, well, first it was asked by the Ministry of Agriculture. So we focused mainly on French experiment, and we focused on experiment that was in really controlled conditions. What I mean is that we see a lot of experiments where you are benchmarking different systems, and those different systems are not conducted in the same way. One is just left as it is, and the other one is really cared. And so it's when you have conclusions like this, and we all have examples of 50–70% of water saving, which is nonsense, because we know that one of the system is privileged for the other. So this is the reason why Claire was saying that we are lacking references.
So I would be very interested in collecting data from whole Europe to the companies here, and I speak for myself, but I guess EIA also would be very interested, so that we could set up a big study as we made for France. We could do it for the whole Europe. It would be very interesting.
Okay, let's try to organize this. A meta study.
I think there are two persons who want to ask questions, Robert Cossette and Michel Istel. Maybe Robert, if you want to say something.
Yes, I will present to you. I'm Robert Cossette. I invented the solar dripper, which is a device used now in Uzbekistan. It's made in France, and it provides local irrigation with built-in.
Maybe we are here for asking questions.
Yes. The question is, Mr. Moll, maybe you are not using all the available information about water saving. In particular, the capability of synchronizing watering with the evapotranspiration. And I'll provide a link on this subject in the discussion if you want. But this can add to the knowledge of the industry, and it can be mentioned.
Okay, thank you. Thank you.
It's a good comment. Thank you, Robert. Yeah.
And Michel, you have something to say?
Yes. Now you have an article about water management in town community, and they said water does not belong to the elected person, and two, but we don't want to privatize it. And also you have articles about projects to reuse or reuse water every week.
Okay. Well, it'd be great, Michel, if you can send the links to the articles, and then we can publish this to everyone. If it's in English, I guess it's in French, but but I think
I think that we should organize a forum on these questions.
Yeah.
Because I know that Claire is working with people that are addressing this question, but maybe she's not comfortable as I am to answer such question.
Okay, and I think Willem Botta want to ask something or to say something.
Yes, thank you very much. If I can put on my camera. Claire, I want to congratulate you on a very nice presentation. I, as an ex-agronomist, I think it was very interesting to see all the relevant things that you looked at. Just a comment, it's more a comment than a question. The one thing that stood out for me from your presentation is the human influence on how important the human interaction is in determining your strategy, planning your schedule, all of that. That is more important than the technology. So in my experience, I also have seen that there's no silver bullet, but we as humans are very important in this whole let's say circle to complete it. So yeah, congratulations, your study showed that, and I do believe that we as humans are still playing a part, and that we can't be replaced by machines. So thank you for that.
This is why training of people is very important.
Yeah.
Thank you. That's it. Is there any other questions?
Any more comments or questions? Francisco. Yeah, please go ahead,
Yes.
Francisco. Yeah.
Good afternoon, everyone. Congratulations to the organization, to the association first for organizing such an event. And it's the first time I'm from ICL, fertilizer company. And to Claire and well, congratulations for the presentations. Thank you very much for the insights. I was impressed to know that tactical losses or reducing tactical losses can improve that much. There may be no impacts on regional, but the impact on nutrient losses is evident, and this is another target. So it's more a call than a question, but maybe, Claire, you have some comment to do. Are you working on this direction of combining the water supply with the optimization, with the reduced nutrient losses? Because it will bring also in INRA, are you close to this? And a call to all the partners in the association to whatever and with whoever they have close to close position. Thank you.
Thank you for your question. Yes, what I have presented today deals only with the quantitative management of water, but also we also work on qualitative management, of course, and both efficiency of water and efficiency of fertilizer are linked, of course, as water is a way to spray fertilizers. And of course, when we work on the volumes of water that are drained, for instance, we work also on the amount of fertilizer that are drained to the groundwater. So you're right, there is a close link between the volumes of water and the amount of fertilizers applied and consumed and so on.
And excuse me again, then this is about qualitative approach. This difference you made, can you please repeat it?
Yes, what I have explained today concerns only the quantitative approach. I mean the different volumes of water at each step of the way of water in the field. But we have also a qualitative approach that is interested in the nutrients that are in the soil water. And for instance, when water losses occur by drainage, we have not only volumes of water lost, but also nutrients or fertilizers in this volume of water that is drained. And of course, we monitor also this loss of nutrients and fertilizer in drainage water or in runoff water.
Thank you very much. Thank you.
Thank you.
Yeah.
Thank you.
Any more questions? Damir.
Yes, Damir. Yeah, Damir, you have question?
I would like to add one of the important aspects of this is how to transform this research information and research finding, how to transform that into some form of guidelines and best management practices, which can be communicated to irrigation practitioners, because this is where most of the important steps about water savings actually occur. If irrigation professionals are leading the project to only one point, all those irrigation systems are later on managed and operated by people who are not directly involved in the industry. So we need to figure out how to transfer this information in the form of guidelines and best management practices, which can be then published or somehow systemized and turned into a methodology of transferring that information to
I think we lost him.
Oh, yeah, I think that Damir was lost.
Yeah, he was in his car.
But that's a good question.
Yeah. So you can answer us. We're gonna transfer later on the answer to Damir.
Yes, it's always the question how to transfer the research results to the operational people. We work, for instance, with the Chambre d'Agriculture. I saw Julie Lebeau among the participants from the Chambre d'Agriculture, and we try to work with them so that the agriculture advisors can make recommendations to the farmers and can make trainings to the farmers. That's very important.
If I can add a word on this one, and I think that this is what we're trying to do when we're working on the what we say on the sustainability on. So we start today, as was explained by Bruno, we're trying to build the baseline, the platform for for this discussion, because you cannot just come with the notion. For example, today Claire spoke about the efficiency of the irrigation. You really need to build the terminology, the vocabulary here, to start talking about what does it mean efficiency, and how do we measure efficiency? Is it only for water? Is it also for fertilizer? It's like there are so many questions that, and everything at the end of the day is coming to the question of sustainability. We cannot ignore this notion that we're trying to save water. We're trying to do not only water. We're trying to do good irrigation, and we need to explain what does it mean good irrigation. We need to explain and we need to use these terms that you just presented now in a simple way, and to translate this to the decision makers as well, so they will be able to take this forward and to help us to open the market of the irrigation and to show how beneficial irrigation is if you do it right at the end of the day. So this is like I think we're all in the same direction, and this private and research and collaboration is I hope it will be very fruitful, and we can continue pushing this for sure. So no further question for Claire. If there are any more questions, please raise your hand. If not, then I would just thank you from the bottom of the heart, Claire, for this presentation.
Thank you
very much.
And yeah, well appreciated. Thank you very much. Fleur, we move to Paulo, I think. No, I see Paulo is here.
Yes. Good afternoon,
you're
everybody.
mute. I'm sorry, you're mute, Fleur. Sorry.
No, it's time to move to the last part of the forum, the innovation and technology session. And this session is consecrated to one of our members who has the opportunity to introduce a new technology and innovation. And this time it's Paolo Antini from Santec company who is going to present when and how much to water new tools for multi-level props data interpretation. So, Paolo.
Yeah, good afternoon, everybody. Can you just confirm that you can see my screen?
Yes, we do.
Yes.
Okay, excellent. So first of all, I want to thank the European Irrigation Association to give me this opportunity to talk about the technologies that we have available in terms of optimizing the irrigation scheduling. As we have seen in the previous presentation, the sensors and the software can really help the water saving. The purpose of my presentation, it is mainly to explain in a simple and effective way what are the instruments that we can install in the ground, and what are the software that we may use in order to manage irrigation in the right way. So let's start with the hardware. I mainly talk about multi-level probe, that use capacitance technologies, so FDR technology. And we are talking about multi-level soil moisture probe. This probe can measure the soil moisture, soil temperature, and soil salinity at every 10 centimeter interval. In particular, the drill and drop probe is a probe that is tapered, so it has a unique shape like a carrot. So we have a bigger diameter at the top and a lower diameter at the bottom. And this is very important because it helps a lot the process of installation of the probe and the removal of the probe. So when you use a soil moisture probe in an annual crop, you need to install the probe at the beginning of the season, and then you need to remove the probe at the end of the season before the harvest. And so it's really important to have a product that's easy to install and also easy to remove. The installation, it is a really critical point for all kind of soil moisture probe. So when we talk about soil moisture probe, we can have the tensiometer that measure the tension in the soil. We can have the capacitance probe, but all of them need to be installed in the right way. It's critical to have a very good contact with the soil, and The soil moisture probe need to be in direct contact with the soil. For this reason, we developed a specific technique and installation tools to achieve an undisturbed soil installation. Again, this is critical because you can have the best probe in terms of accuracy, in terms of technical specification, but if you don't install in the right way, you don't get the good data. So it is critical to select the representative site where to install the probe in terms of macro area that need to be representative in terms of soil texture, slope, and then it's very important to decide where to install the probe in the micro area, especially considering the distance from the crop and the distance, for example, the drip irrigation, the distance from the meter. So the main aim of the monitoring is to monitor the roots, and so we need to install the probe in the root zone of the plant, and of course we want to read the irrigation. So an easy example, if I install the probe too far away from the dripper, I can't see the irrigation. So it's really critical to decide where to install the probe and to install the probe in the right way with the right tool. Okay, so why a farmer, an agronomist should use a probe? Okay, we try to answer to 3 questions using the data that comes from multi-level probe. How much to water in order to avoid to irrigate too much or too less? So what is the right amount of water that we need to apply? When to irrigate, avoiding stress for too less water. And if the grower have different fields, to understand what is the priority of that field, because maybe they have just one well and just one pump, and they need to irrigate several plots. So when you have this data, you can easily understand what is the priority of this plot. Okay, how to answer to these questions, no? Because they are easy questions, but it's not easy to answer as we have seen in the previous presentation. But the aim of my presentation today, it is to show in a very easy way some graphs that can help to answer to these questions. So let's start with we will see the graph, and then we will see some new tools that help the process of data interpretation. So this is a very typical soil moisture graph, okay, where we have in the x-axis the time. In this case, we have the days, so we have July and a little bit of August 2022, and in the y-axis we have the soil moisture content. Okay, this is a staked graph. What it means? It means that we have always represented the line of the first sensor in the top part of the graph, and the line that represents the bottom sensor in the bottom part of the graph. So each line has a separate y-axis, and this is very important because it helps to visualize what is going on in the field, especially for the people that is not usual to graphs as growers. So nothing new. We have these technologies from many years. Consider that Sentech developed the first probe 30 years ago. Nothing new, but it is the way how to look at the data. So with this data, for example, with this graph, you can easily understand your irrigation depth, and you can compare with the root activity. So as you can see here, we have several increase of waters that are the irrigations. In this case, they irrigate every 2 days. And then after the irrigation, you see this typical staircase effect. Okay, so you have the irrigation, and then you have day, night, day, night, day, night. And you have this staircase effect in the level of the soil at the depth where you have active roots. Because what happens in the soil is that the plant uptake the water during the day, and so the soil moisture goes down. During the night, it stays almost flat. So nothing new. What is new? It is the way how now show the graphs to the growers, because it becomes easier. So we try to make the life easier for the growers and for the consultants. For example, with this kind of graph, where you can easily visualize the irrigations with this stalactite, okay, blue stalactite, that help you in visualizing the depth of irrigation. So in this case, we can easily see that the depth of irrigation, it was 50 centimeter, okay? And the other tool, it is to visualize, help in visualize the root activity, the water uptake. So there is an algorithm that create these ovals, okay, that have the same color of the line that represent the soil moisture trend at that particular depth, and the height of the ovals, it is the amount of water, and the wide, it is the time. You can also see if you place two rulers at the beginning of the day and at the end of the day, you can see how many millimeters you are losing every day at each level of monitoring. But again, we have three questions: when to water, how much to water, and what is the priority. This graph helped me in answer to the question how much to water, because I can check each irrigation and compare the depth of irrigation with the depth of the active roots. Usually the aim of the irrigation is to stay in the active root zone without to go deeper. Again, we have another algorithm that simplify even more the visualization. So in this case, we see two panes, and we show the same data in two different ways. So if we concentrate now in this upper pane, you see that we have, again, a 60 centimeter probe with 6 levels of monitoring. And so we divide the pane in 6 layers, okay? And we have colored layer where we have active roots, and we have white layer where there are no active roots, okay? So you can easily see where you have active roots. And then when there is an irrigation, we create a drawing of the roots, of the depth of the roots, and the drawing of the depth of irrigation. Okay, then if you have, if these two match, so the depth of irrigation is the same of the depth of the active roots, you have a green color. It means you are okay with your irrigation time or with your millimeter. Or if you are too short, you have a red color, okay? It means that you need to irrigate more. In this graph now, we don't have the example, but if the irrigation is too deep and it goes deeper than the roots, you will have a blue color. So in this way, even if a grower or a person that is not familiar with the soil moisture graphs can easily understand if they are irrigating with the right amount of water. And so they can answer to the question, how much to irrigate. Okay, then we have the other question, when to irrigate. To answer to this question, we usually do another graph that is named summed graph. In this graph, we sum all the values that comes from all the layers, and we have just one line that is the total amount of water that is available in that soil profile. This is also the graph where we set the budget lines that help the grower to understand what is the right amount of water for the plant. And as you can see here, we have the green green area, no? That is the comfort area for the crop. Then we have the blue area where there is too much water for the plant, and then we have the red when there is the stress, and the yellow area when the grower need to start with the irrigation. Okay, this is still how to set this budget line. Okay, how we can decide where the graph need to change between blue and green, and where need to change between yellow and red. So this is still a manual process, but we are working in suggesting this budget line, again, thanks to the algorithms. So at the moment, how we decide what is the full point, okay? So usually what we do, what our dealers are doing, and the people that use the multi-level probes that can be sent or other probes, it is to install a probe and then wait some days, some weeks, usually after 2-3 irrigations, start to analyze the trend. And then to decide the full point, what we usually do, we select the best irrigation in terms of depth. So the irrigation that increased the soil moisture level at the depth of the roots. And then we check what it was, the total amount of water in the soil at that day, and we select that as the full point. Okay, so then for the next irrigation, the growers has a reference of what is the full point. Okay, now I'm simplifying, of course, but because, of course, something that we need to say is that this point can change during the season, because the soil compaction can change, because the root growth, etc. So you need to check during the season this full point, but this is the way how we select it. And another thing that I want to show here that you can see very well, it is the usual day and night activity. So this is the water uptake of the plant during the day, and so the soil moisture goes down, and during the night it stays almost flat. So we have day, night, day, night, day, night. So let me say that when you install a soil moisture probe and you start to look at the data in this way, you not just understand if the soil is wet or if the soil is dry, but you have a response of the plant. Okay, so the plant can become your sensor. Okay, of course, with the limit that you are monitoring one point, so you need to select exactly the right point, but it is a response of the plant. Okay, so we have seen how to set the full point. Let's now see how we can set the stress point and the refill point that answer to the question when to irrigate. Okay, so we have seen how much, let's see when to irrigate. So usually this is a typical soil moisture trend graph when you don't irrigate often, and what you usually see is that when the soil moisture goes down to a certain level where the plant starting to struggling to extract the water, you start to see a slowdown in the water uptake. That it means that the stairs become slower and smaller and smaller during the day. Okay, so this is the way how we can understand that the plant start to struggling to extract the water. But if we are not sure about the weather condition, we are not totally sure if the slowdown in the water uptake, it is due to the too less water in the soil, or it is due to a different weather condition. So what we found very beneficial, it is to compare the water uptake of the plant with the evapotranspiration, because as I said, you can have a decrease of water uptake due to different weather condition. For who is not familiar with the evapotranspiration, Of course, evapotranspiration is influenced by environmental condition, mainly about temperature, relative humidity, wind, solar radiation. So of course, if today is cooler and less windy than yesterday, it is normal that I have a less water uptake of the plant. But if you have the slowdown in the water uptake at the same evapotranspiration condition, you are pretty sure that you are going into the stress due to less water in the soil. So what we are doing now is to compare the root absorption, so the daily water use measured by the probe, with the daily evapotranspiration. And the software that we are using is now suggest having these two data. You can get the evapotranspiration, just to clarify, from a weather station that you have in the field that can estimate the evapotranspiration thanks to some formula. The most used is from the FAO. Or you can also get the evapotranspiration from weather services that base the estimation on the satellite imagery and the weather station network. So you can buy this data also if you don't, and it's pretty affordable also if you don't have a weather station. So having these two data, we can now suggest what is the stress point that then need to be confirmed always by the agronomists or by the consultants. Also because this is a very generic thing. So I want to manage the crop in the green area to avoid the stress, but it's not always true. For example, here in Italy, in processing tomato, we want to create the stress during the maturity. So in the last 10 days, we stopped the irrigation and we want that the plant goes into the stress to increase the sugar content, to increase the brick. So of course there are different kind of irrigation strategies that you may apply. But let me simplify. Usually we want to stay in the green area, and so we want to irrigate before to get into the stress. Okay, last slide. This is another way to visualize the soil moisture trend that in this graph we see in the below pane. So in the below pane we have the soil water content. In the meanwhile, in the upper pane, we have this time the volumetric ion content that give us an idea about the salinity that we have in the soil. And this is another way that we have just launched to visualize the data. So in this case, in the below pane, you can see that you have blue area. Most is the blue, more is the moist in the soil. More is the white, more is dry is the soil. Okay, so of course you have the irrigation that wet the soil and then dry out during the days. And in this example, for example, you may see that at 50 and 60 centimeter is always pretty wet, no? Because probably there are not roots that extract the water, but the root activity is mainly in the first 40 centimeter. And the same things you can do for the salinity. So thank you for the attention. I've been pretty quick, but I'm available for any question. And of course, if you want to go deeper in any topic.
Thank you, Paolo. So this was very interesting. Any questions from the audience with us? While waiting for the questions, I have one comment, maybe even a question for you, Paolo. But because I'm interested to understand. You're talking a lot about the visualization of what you're doing, the simplification of the understanding what the sensor gives you. Do you think that this is the blocker today? If you look on the market and how to penetrate more and how to use more sensors to connect to the idea of doing better and to connect to the idea of having better efficiency and so on. I feel that it's a human behavior that really need to change, because you can explain the graphs and everything is nice and cool and visually speaking, it's beautiful. At the end of the day, what is the blocker for, and how do we use the sensoring? How can we use the sensoring in a better way to implement it in the field to get the results? Do we have references of what is happening when you use sensoring or not, or is it only mainly the fact of the human behavior? People can enjoy it, but they don't really follow what it means. So how do you see this market evolving?
Yeah, I think that the main issue is the education. So we need to really do training and explain the technologies, and this takes a lot of time and time to demonstrate. And in agriculture, you need to wait the end of the season, and then you need just a year to demonstrate the technology, and then when you get the confidence from the grower, they can try to install one probe and another probe, and it takes time. It takes a lot of time. Consider that these technologies has more than 30 years, and we started to work with the universities. We have many papers, we have case studies that demonstrate the water saving from 20 up to 50%. So it's something that is not new. It's not a new concept. It's there and it's ready. And I think that the two things will help the development. One, it is this kind of visualization help a lot the adoption of the technologies, because the people is less care about it. So it's easier to understand. And the other thing is the artificial intelligence, the algorithms that will help the process of data interpretation. Because for now, the limit of these technologies is that the problem is not to buy a probe and install a probe in the ground. It is to use the probe. And to use the probe, you need to have a technician. You have to have the people that care of it, that do the data interpretation and provide this service. So the limit is the human people that will do this kind of work. So probably in the future, the two things that help the process of spread the technologies out in the market, it is software and artificial intelligence, I guess.
Thank you. I say that Bruno and Robert would like to
answer. One question. In fact, I'm just interpreting the question of several persons. Mr. Mandieta, Mr. Rashwan. Really interesting, really pedagogic. Thank you, really. How do you manage the case of different? I would say the general case of the differences between the different soil layers. For example, in a standard cell soil, you will have about 80% of the roots in the first 10 centimeters, and then you will have the decrease in the root zone in the density of root when you go further. So how do you manage it, and are you able to take in account different quality of soil with different layers?
Yeah, so what we have seen in terms of root development, in terms of water uptake, is not an estimation, but is what we measure in the soil. So if in a soil layer you have more roots, probably you will see a bigger uptake of water in that layer compared to the other layers. So let's say that we measure what is happening in the different layers. And so with the data interpretation, we should be able to understand what is the plant and the roots behavior in that layers. And sorry, the second question, it was
on the quality of soil in different layers.
Quality of soil. So the soil moisture probe, capacitance probe can be used in all the soil type. we can have some problems in the heavy clay soil because the soil sometimes crack, and so you can lose the contact with the soil. But this is a problem with all kind of soil moisture probe. But generally speaking, we can use in all the soil type. A critical point, it could be where to install the probe when you have different soil type in the same plot, okay? And when the people ask, how many probe do I need, okay? So I usually answer that there are two answers, okay? There is a theoretical one and the practical one, no? Because the theoretical one is that you should have macro area that are homogeneous in terms of soil texture, slope, crop, irrigation system, etc. And then inside this macro area, you should have one probe to manage it. But then I would say that if you have a plot where you have more than one macro area, but you are not able to differentiate the irrigation in that macro areas, do it make sense to have more than one probe? Usually not. So this is more a question when you design the irrigation system. So it would be very important when you design the irrigation system to have macro area homogeneous in terms of soil texture and slope. But in many cases, we operate in plots where they have more than one macro area. And so the practical answer is to install one probe in the area that is the majority of the field. Okay, so if you have the 95% of sand and then you have the 15 of loam, you will stay in the sand because it's what is the most important for your production.
Okay, thank you.
Another question from Robert Cosset. Again.
Yes, I found this presentation quite interesting. I was wondering information about the duration of the watering cycles and what were approximately the flow rates that were used during those typical experiments.
Yeah, regarding the graph that we were visualizing, that was processing the tomato irrigated by drip irrigation, and the irrigations was about 4 hours, from 3 to 5 hours. Yeah. An interesting thing is that using a multi-level soil moisture probe, you can estimate the infiltration rate and the infiltration time. Because if you zoom in the graph, you can zoom it and you can place a ruler in the first layer when you start to see the increase, and then you can put another ruler in the second, the third, etc. And you can see the time. And you can also understand a little bit regarding the soil texture. No? Sometimes we receive the data and we don't know nothing about it, and the people ask us, okay, let's interpret it. Not easy, but look into this, for example, to the infiltration time and infiltration rate, you can estimate the soil texture.
Okay. Thank you.
Thank you.
No worries.
Okay, Flor, we good with the questions or the comments?
No, I think there are other questions in the chat.
Yeah.
Ivan Merabal, he said, what about the influence of the soil and water conductivity in the humidity reading? What is the limit before getting too much error? Some manufacturers said 3 ECUs.
Okay, we developed a frequency, a specific frequency that is not influenced by salinity and by temperature, so it's all influenced by the water. So we have cases where we have used the probe up to very high salinity concentration. And what we do to measure the salinity is to change this frequency. So we use two frequencies, one to measure the moisture and another one to measure the salinity using a mathematical model. I know that in the market there are other sensors that are influenced by the salinity, but it's not our case.
Okay, thank you. And there is another question from Andreas Maurer. What is the limit in salinity these sensors can work?
Yeah, same. I I can answer with an email if they want to know specifically the salinity, but consider that we used this probe to manage salinity problems, and so they can work also in high concentration of salts. There is no any influence as for other technology.
Okay. Okay, I think that's it. Any other question?
I think there is a question here about how far do you place the sensors from the dripper of Andreas?
Okay, good question. Depending on the soil type, but usually we stay from 10 to 25 centimeters from the dripper. So more is the sandy soil, more is close to the dripper, more is the clay soil, more is the fast, yeah, depending on the soil type. But it's very important question. The distance from the plant and the distance from the emitter. So usually when we are in the annual crop, we stay at about 20 centimeters from the plant and 15-20 centimeters from the emitter. When we work in perennial crop, it's different depending on the crop, but let's say more or less 30 to 40 centimeters from the trunk, and again 20 centimeters from the dripper. But installation is critical, very important question.
Yeah, I agree as well. Yeah, we use it as well. So, okay, I think that we came to the end of the time. The questions keep on popping up. I think that the best way is that once this we're gonna publish the presentations and everything, and then that's part of what we're doing here. Feel free to contact directly each other and to continue the development of the discussions on a professional way. So I think that we've came to the closing session, the end of this forum. Paolo, thank you very much for your presentation. I really appreciate it. It was well appreciated. Anyone would like to add before I'm taking the last notes here? Does anyone would like to add anything to the conversation, a general point of view, the work of the association, the working groups, anything that you would like to add? So please feel free to share with us. But meanwhile, while we're waiting, so feel free to raise your hand or to open the microphone. I would just like to first of all to thank you all for participation in this forum. It was quite active forum, and we like it a lot. This is exactly what we're trying to do to develop these discussions, and I saw that there was. I was happy to see that there was a lot of interest in the topics. I'd like to take this opportunity to thank all the people that are involved in the Irrigation Association actively, the working group leaders, for all the daily work we're doing. Thank you, Bruno, for your presentation today. Thank you very much, Claire and Paolo, for your very well-made presentations with a lot of interest. Of course, we will share it. I guess, Flor, that we'll share the presentation after the meeting with the approval of from your side. A big and special thank you, Fleur, for preparing the event, and Jean-Maurice here with me for following the ongoing support. If anyone would like to add anything, this is the last moment in this forum. If not, well, I hope that I'm going to see some of you in the coming events. I didn't get a chance to visit the Architecnica last week in Germany, but for those of you who are more locally in the French area, so maybe I'll meet some of you, hope to meet some of you in the Montpellier CTV next week, or maybe in January in the Cival. So please, if you are participating in these exhibitions, don't hesitate to pass by, say hello. We don't have as an association a stand, but you can find many members of the association there. You can find me. Usually I'm in the stand of Netafim. That's what I'm doing on my daily job. So please come and say hello, and I would love to chat with you. I wish you all a very nice evening, almost afternoon. Sending, as always, the actuality, sending the prayers to the security and the health of the people in Israel and Palestine. And we all pray for the end of the war. And thank you very much for participation. And the forum is closed. Thank you. Have a nice weekend.
Bye.
Bye-bye.
Thank you. Bye.
Thank you. And congratulations for the presentations.
Bye.
Thank you. Bye.
Thank you. Bye.